Look up at the night sky. Station is at the heart of it all. The ISS is about the size of a football field. It's so big you can actually see it from Earth with the naked eye. The station is made up of different modules. These modules are like rooms or sections. There are labs for conducting experiments, a place to sleep, a gym to stay fit, and even a window with breathtaking views of Earth. Can you imagine waking up to that every morning? The station provides everything astronauts need to live and work in space. You might be wondering, how does the ISS stay up there? It's a fascinating question that combines the wonders of physics with the marvels of human engineering. It all comes down to physics, specifically gravity and orbital mechanics. These principles are the backbone of how the International Space Station, or ISS, remains in its orbit around our planet. Imagine throwing a ball. The harder you throw, the farther it goes before hitting the ground, right? Now imagine if you could throw that ball so hard that it never hits the ground. Instead, it keeps falling around the Earth. The ISS is basically being thrown so fast that it continuously misses Earth as it falls. This speed is crucial. It needs to travel at about 28,000 kilometers per hour, or roughly 17,500 miles per hour to maintain its orbit. This is what we call orbit. An orbit is a delicate balance between the forward motion of the ISS and the pull of Earth's gravity. If it were to slow down, it would start to descend towards Earth. If it were to speed up, it could escape Earth's gravitational pull and drift off into space. And because there's almost no air resistance in space, it can keep going and going without needing an engine. On Earth, air resistance slows down moving objects, but in the vacuum of space, there's nothing to slow the ISS down. Another cool thing about being in orbit is microgravity. This unique condition allows astronauts to experience a sensation of weightlessness, which is both fascinating and useful for scientific experiments. It's not that there's no gravity, but it's very weak. The ISS and everything inside it are in a state of free fall, creating an environment where gravity's effects are minimized. This makes everything float, and it's one of the reasons why astronauts can move heavy objects with ease. In microgravity, tasks that would be difficult on Earth become much simpler, allowing for unique scientific research and experiments that can't be conducted anywhere else. Scientists take advantage of this environment to study a wide range of phenomena, from the behavior of fluids and combustion to the growth of crystals and biological organisms. The insights gained from these experiments can lead to advancements in technology, medicine, and our understanding of the universe. The ISS orbits Earth approximately 16 times a day, giving astronauts a unique perspective of our planet. They witness breathtaking sunrises and sunsets, and they can observe weather patterns, natural disasters, and the impact of human activity from space. This vantage point allows for important Earth observation and environmental monitoring. By studying our planet from space, scientists can track changes in the climate, monitor deforestation, and even predict natural disasters, helping to protect and preserve our world. Communication with Earth is vital for the ISS. Astronauts stay in constant contact with mission control, sharing data, conducting live experiments, and even participating in educational outreach to inspire the next generation of scientists and explorers. Living in space also presents unique challenges. Astronauts must maintain their physical health through regular exercise to counteract the effects of microgravity on their muscles and bones. They follow strict exercise regimens to stay fit and healthy during their missions. Nutrition is another critical aspect of life on the ISS. Astronauts need a balanced diet to ensure they get all the necessary nutrients. Meals are carefully planned and prepared to provide the energy and sustenance needed for their demanding work. Even sleeping in space is different. Astronauts sleep in special sleeping bags attached to the walls to prevent them from floating around. They must adapt to the unique conditions of space to get a good night's rest. The work done on the ISS is a testament to human ingenuity and collaboration. It represents the combined efforts of multiple countries and space agencies working together to push the boundaries of what is possible. As we look to the future, the ISS serves as a stepping stone for further space exploration. It provides valuable experience and knowledge that will be crucial for missions to the Moon, Mars, and beyond. The lessons learned from living and working in space will pave the way for humanity's next great adventures. When astronauts return to Earth, they bring back not only scientific data, but also a renewed perspective on our planet and our place in the universe. Their experiences inspire us to continue exploring, learning, and reaching for the stars. The ISS is more than just a space station. It's a symbol of what we can achieve when we work together. It reminds us that the sky is not the limit, but just the beginning of our journey into the cosmos. Section 4, Space Living 101, From Brushing Teeth to Sleeping Upright. Living in space is a unique experience that requires astronauts to adapt to a completely different environment. The International Space Station, or ISS, is a marvel of modern engineering, but it comes with its own set of challenges. One of the most significant differences is the presence of microgravity. This means that the usual force that pulls us down to the ground on Earth is almost non-existent in space. As a result, astronauts float around the ISS, which can be both fun and challenging. Remember that microgravity we talked about? It affects everyday life in fascinating ways. Simple tasks that we take for granted on Earth become complex in space. For instance, brushing teeth is not as straightforward as it seems. In microgravity, water doesn't flow from the tap. Instead, astronauts use a small amount of water from a pouch to wet their toothbrush. They then use a no-rinse toothpaste, which they spit into a cloth rather than a sink. This prevents water droplets from floating around and causing potential hazards. Eating in space also presents its own set of challenges. Astronauts have to eat special food that won't crumble and float away. Crumbs can be dangerous as they can get into equipment and cause malfunctions. Therefore, most space food is either in liquid form or comes in sealed packages. They can't just drink from a cup either, they use special pouches with straws. These pouches are designed to prevent liquids from floating away, which could be a nuisance and a safety hazard. Drinking in space is an interesting experience. The liquid forms a blob and sticks to the straw, allowing the astronaut to sip it. This method ensures that the liquid doesn't float away and cause problems. Sleeping is also different. Astronauts sleep in sleeping bags, but they have to strap themselves in so they don't drift around. The sleeping bags are attached to the walls of the ISS, providing a secure place to rest. The sleeping quarters are small, but they offer a private space for each astronaut. They can close the door to their sleeping pod, giving them some privacy and a sense of normalcy in an otherwise unusual environment. Even going to the bathroom requires special equipment. The space toilet uses airflow to direct waste into the proper containers. This prevents waste from floating around and contaminating the living environment. It's a whole new world of adapting to life without gravity. Every aspect of daily life, from personal hygiene to eating and sleeping, has to be rethought and adjusted to fit the unique conditions of space. Despite these challenges, astronauts manage to live and work effectively, contributing to our understanding of space and paving the way for future exploration. Section 5: Powering the space station, sunshine and batteries. Out in space, there are no power outlets. So how does the ISS get the electricity it needs to run all its systems? The answer is solar power. The station is covered in giant solar panels that convert sunlight into electricity. But what happens when the ISS is in Earth's shadow and can't get sunlight? That's where batteries come in. The station has massive batteries that store energy collected by the solar panels. This ensures a continuous power supply for the astronauts and all the onboard equipment.